So the concept of a dynamometer isn't new. In fact, this technology has been around for over 100 years and is really being developed to help us assess muscle strength in clinical populations. Although that basic concept has obviously remained the same, the technology has moved along quite a lot, as you can see from this figure taken from the VALD Health website. Modern devices then are smaller, more accurate, and capable of integrating their data into broader performance systems. So, as of now, we have really three main categories. We have the traditional analog handheld dynamometer. We also have a standalone digital version, which provides a digital feed out in real time whilst you're conducting the test. And now we have our app-enabled handheld dynamometers, which combine the most accurate hardware systems with these integrated software solutions. So what exactly do they try to do? Well, a dynamometer is a device simply that measures force, specifically the amount of force that someone is either pushing or pulling against it with. And that gives us a representation of their strength in that particular muscle group or joint that we might be testing. The dynamometer typically houses a load cell, and this then converts the mechanical force applied to it into an electrical signal. The signal is then translated into a force value, typically in newtons, but we can, of course, convert it into other measures of mass, such as kilograms or pounds. This, again, is based then on Newton's third law, the law of action-reaction, that for every action, there is an equal and opposite reaction. So when one object or testing limb or joint exerts a force on a second object, in this case, the handheld dynamometer, then that second object exerts an equal force back onto the first object. That's key, as we'll come back to in a moment when we dive into some of the reliability around this kind of technology. And traditionally, these devices can perform one of three types of testing. They might be used for compression strength testing, tension strength testing, or grip strength testing. The dynamometer also frequently includes an inclinometer, so we can also conduct range of motion testing with the same device. Now, the grip strength test does what you would expect it to based on its name. The compression dynamometer is typically used for traditional handheld testing, and then the tension dynamometer is more commonly used for fixed point testing, where it is attached to a fixed point. So handheld dynamometry then is useful in a whole host of different ways, whether we want to assess unilateral strength, perhaps then to analyze asymmetries between the left and the right sides. And with that in mind as well, it's particularly useful to track progress through rehabilitation after injury and through that return to play period as well. A lot of the tests that are used with handheld dynamometers are actually tests that we've talked about in this series before. So tests such as hip abduction and adduction, or shoulder strength testing, or isometric mid-thigh pull, all of which maybe can be tested in other ways, arguably in more detailed ways with more advanced technologies such as the force frame or force plate. But these is worth remembering that these dynamometers, the handheld dynamometers in particular, enable that more portable, accessible testing option across a lot of these test types as well. Now, it's worth noting that the challenge historically with dynamometers, particularly handheld dynamometers, has been their reliability. And of course, the improvements in technology and digital devices has greatly improved their accuracy and their reliability. There remains the factor of human error, especially when we're performing compressive muscle testing assessments, because, as we mentioned earlier, as per Newton's third law, these require the assessor to apply an equal and opposite force to the testing limb. This can then make us vulnerable to both inter-tester reliability issues and intra-tester reliability issues. But of course, this is what makes our protocols so key. We need to make sure that we have standardization, we're using consistent cues with our athletes, and that same protocol to make sure that we are mitigating the risk of poor data quality. And VALD's Dynamo app actually has inbuilt testing protocols with videos as well to really help make sure that we are maximizing our reliability both between testers and within for the same tester in different trials as well. So let's dive into the Dynamo range then. VALD offers 3 different handheld dynamometers devices in this range. Each is built around similar technology, but recommended for different contexts. So we have the Dynamo Lite. This is the most compact option. It doesn't have a display, but it connects to the VALD app through Bluetooth. This, of course, is its most lightweight, most portable, and ideal for quick assessments, particularly in the clinic or if you're traveling on the road. The Dynamo Plus then has this inbuilt digital display, so we get instant feedback when we're conducting testing. And it also connects with various VALD smart attachments to enable a whole range of different test types. Then at the top end, we have the newest member of the range, which has a larger ergonomic case and improved internal components, giving things like enhanced sensitivity and battery life. But crucially, it has this capacity up to 10,000 newtons, so 1,000 kilograms or 2,200 pounds. And so that means it can even be used for maximal isometric mid-thigh pull strength testing. Now, I'll put a link below to the Dynamo webpage. So from there, you can see all the specifications in detail of each of these devices in the range to get to know each of them and explore what might be the best solution for you. And of course, you can reach out to VALD through that webpage to discuss it directly with them as well. From a data perspective, then, all 3 of them connect directly to the VALD Hub, so their cloud-based data management system. So this allows you to store, analyze, and visualize your data over time, as well as looking at all your different data streams for the various VALD technology that you might be collecting data with. Then there's a few different metrics that might be of interest to us. Clearly, it gives us this peak force measure, and this really is our go-to metric for representing muscular strength. If we're conducting that across different limbs or in different positions across different joints, we might want to look at the asymmetry between the left and the right side, or perhaps the imbalance within a joint, such as looking at abductor to adductor strength. And I think if that's of interest to you, then definitely firstly take a look at my asymmetry calculation conundrum video, and then also dive into the hip and groin testing video, because that talks about these measures across the different joints. As I reiterate in each of those videos, it's not necessarily a good or bad number. It's critical that we have context to our asymmetries and really be collecting data over individuals over time to see the trends and the norms for their specific profile. The dynamometers also give us a measure of time to peak force, and this can be really interesting, particularly in those rehabbing from injury, to see how quickly they can reach that maximum. If you are testing with that metric in mind, you want to make sure you are cueing them to try to reach that max force as quickly as possible. We also then have rate of force development measure. This is all about the speed of force generation within particular time points, and is a topic I've dived into in more detail in a specific video. And this really gives us insight into how explosive they are, and again in rehab, how quickly they get back to their norms post-injury for the ability to generate force quickly, which of course is so critical in many sporting endeavors. If you want to explore then the Dynamo range in more detail, I'll put that link below, and definitely make sure you check out the rest of our videos in this athlete testing series in collaboration with VALD. Thanks for watching, and I'll see you in the next Sports Science Insights video coming very soon.